Okay, so let's go. Okay, are you there? Okay, so let's go. So today we'll be looking at Python numbers. Let me type again. So Python numbers. So that's what we'll be looking at today. Now we have three numeric. We have three. I'm writing now. There are there are there are three numeric types in Python. Okay, so there are three numeric types in Python. So one, one is int that we looked at yesterday. Right, we looked at int for integers yesterday. So the second one is float that we looked at yesterday. Then the third one is complex. So if you did mathematics, you will know that we have complex numbers. So the first one is int. Are you writing them down? The second one is the second one is float. Then the third one is complex, like this complex. So let's quickly look at the first one. So basically, it's complex. So I told you yesterday that integers, integers, integers are numbers with no decimal. Numbers, Abi, right? I said numbers with no decimals. So, for example, 100 is an integer, right? Minus 10 is an integer. 0 is even an integer. They are all integers. But then I said number 2, which is float. I said they are numbers with decimals. Number with no decimals. 100.4 is a float, right? Minus 0.5 is a float. 1.3 is a float. So numbers with decimals are called float. Now, the third one is complex. I didn't explain complex yesterday, but let me explain it today. Now, I don't think you need complex at this level, but then I don't think we need complex at this level. But let me just explain what complex is. So, complex basically is a mathematical um, type of numbers. So, it's like z is equals to 1j, like this, 1j. So, this this z represents the vertical, while the j represent the x-axis. So it's basically for of course it's complex, and they call them complex numbers. So I'll not really go deep in that. So, but we will see example on that. So let's quickly move. So remember yesterday I said to verify the of any type of any object or any object in Python, use the type function, right? If you remember, say the type function, if you want to verify the type of any object in Python, you make use of the type function. Now, let's try it out. So the first one we'll be looking at is integer. So let's try integers and confirm. So let's go. Let me declare, let's say x is equals to 1, right? Let's say x is equals to 1 and y is equals to 1, 2, 3, 4, 5, 6. Okay? Are you following? And say z is equals to minus 3, 4, 5. So if I want to get the value of x, I'll just say print x. If I want to get the value of y, I'll just say print y. If I want to get the value of z, I'll just say print z. No problem. But then let us verify the type of object that x is. No, that x is. So I will say print, then type, then our variable name, which is x. It say x is what? An integer. Remember we declare x as 1. So is 1 an integer? Well, yes, 1 is an integer. So it verified that x is an integer. Now, if I print the value of, and if I want to check the type of object that y is, it will say y is an integer. Remember that I declared y as 1, 2, 3, 4, 5, 6, 7, or thereabout like that. Right? It confirmed that y is an integer. Now, if I want to check the type of object that z is, remember z was minus, I think minus 3, 4, 5. Yes, let me quickly confirm. Print z minus 3.5 and 345. Good. So let me confirm the type of data that z is. I'll say print type of z. See, class is an int, right? So it means it's an integer. So that is that. So that is basically an integer. So that is an integer. Please, that is an integer. Please, that's an integer. So remember, any number without decimal are what? Integers. Good. Now let's look at number 2, which is float. Now remember I said float, um you can say float is a number a number containing, it could be either even one or more decimals. Float is a number containing one or more decimals. So we could just say float is a number with decimals. Float is a number with decimals. So 12.4 is a float, right? Minus 12.5 is a float. Minus 0.6 is a float. 0.5 is a float. 2.3 is a float. 7.8 is a float. So those are float number. So let's declare a variable and say x is equals to 1.20 and say y is equals to 1, or let's say 3.9, and say z is equals to minus 45.9, right? So the first thing we'll do, let's print out the value of x. Print x to verify we had 1.2. Print y had 3.9. Print z we have minus 4.5. We have minus 445.9. Good. Now let's check for the type of object that x, y, z are, either whether they are integer or float. So I will say print, then what next? Then good. Type x, we say class is a float, right? Then let's check for y. Print, then type of y. Say class is a float. Then print type of z. You see, z is a float. Remember we had 1.20, if I'm right, um, 3.9 and minus 35 point something, pardon. So these are off float. So if you see this any day, anytime, they are all float. Yes. So let's look at um, the third one. So the third one is complex. Complex. So in mathematics, we have, I don't want to talk mathematics here. We have imaginary number and real number. Can you quickly Google? Okay, let's just move. So we have imaginary number. So in complex number, real numbers, is it real numbers or real nice? I think real numbers. You can just quickly Google at your side. I think real numbers are represented, yes, are represented as, yes, are represented as I, while imaginary imaginary numbers are represented as J. Yes. I real numbers are I, abi, and imaginary numbers are I. Wait, imaginary is J or I? Okay, what of real? What of real number is I, J should then imaginary should be J. Okay. Uh-huh. Like this, A plus B, right? Right. Okay, so good. So let me just show you examples. Let me show you examples. So I want to declare a variable for complex number. I'll say, um, so remember you told me A plus B, right? Right? So if I want to declare a complex number variable, I will say x is equals to, let's say our A is 5, then plus our B is 7j. Now, this 5 is I, this 7 is j. This 5 is the real number, this 7 is the imaginary number. No problem. Let me declare y as maybe 8j and z as minus 2j. No problem. No problem. I want to try something. You see? This is how we represent them, sha, in mathematics. This is how we represent them. Like they're always written inside brackets. So you can have, so you could have something like this. You could have something like this. So one, one plus this guy. Say four plus. Now, if you want to do this mathematically, the mathematical way, the real numbers will come together. The imaginary numbers will do what? Come together. So if I if I enter now, no problem, and I print, you will see what to do. X. You see, that summed it for me. I see 5 plus 4 is what? 9. 7 plus 8 is what? Good. I seen, so that is complex number. But let us check the type. Let us check the type. We say print, right? Type and say X. You see, class is what? Complex. Class is complex. So let's print for Y. Class is complex. So let's also print for Z. Class is what? Complex. Yeah, so those are the basic types of numbers that we have. Three numerical types of number that we have. We have int, we have float, and we have numbers. Complex. Now, let's quickly look at type conversion, because mind you, you can convert an integer to a float. Do you understand? So, type conversion. So let me just quickly write. You can convert from one type to another with so yesterday I said functions are reusable code. And remember when I was saying, if you want, instead of writing a dictionary like this with something like this, right? Abi, you can just write dick like this and say name is equals to maybe Joshua, comma age equals to 49. Abi, so like this for dictionary. So I said int like this is a function, and float like this is a function. So complex is also a function. So all these things are reusable code. So they are already written for us to use. So all we need to do is just to utilize them. So if you want to convert from one type to another, we need to make use of these guys. We need to make use of the integer function and the float function and complex function. So let's go. Let's try. Should we try? So now, let me ask you a question. If I say x is equal to 1, what is x? Integer or float? Okay. If I say y is equals to 2.8, what is y? If I say z is equals to 3j, what is z? Complex number. Good. Now, I want to convert. So I know x is integer. So I want to convert from integer to float. I want to convert this x there is an integer like this. I want to convert from int to float. So I want to convert from int to float. Remember x is integer, y is float, and z is complex. So I want to convert x from integer to float. So this is what I want to do. I will declare a new variable, say a is equals to, I'll just say float of x. Do you know what I just did? I said I, I said if you want to convert from one type to another, you will need to make use of these functions. Put them down. Int for integer, float for float, and complex function for complex numbers. So meaning if I want to convert this x that is integer like this, I'll just need to call this function and put x inside this parentheses. It automatically converts it to float. If I want to convert this 2.8 that is a float to a complex number, I just to call complex and put this variable name inside, right? If I want to convert this 2.8 that is a float, I just to insert this variable name inside this int. Okay, so let's try. Mm, yes, is why I'll put there. Just why. Just why. Yeah, so let's try now. So I'll just say, so because I want to print out the type, let me create a new variable and say a, right, is equals to float of x, no problem. If I print a now, you see what's gonna happen. What is 1.0? Float. So remember that x was an integer before. So I've converted x that's an integer to what, a float, using this function float x. So let's try and convert a back to a integer. So I just say b is equals to, if I want to convert to an integer, which function will I call? So let me put a there back. I want to convert this 1.0 back to 1, which is an integer. A, print b. So we've gotten our 1 back. Is it clear? Okay. So let me convert um y